because I need to tilt the laptop. But we will do as I planned out for the first problem. We distribute the sign first. So this gives us 3x and then minus x or minus 1x, whatever you prefer to put it in, right? And then this negative.
But that's what I had said before. I was telling you, I said 1x and minus x and negative 1x is pretty much the same thing.
Okay. Yeah.
Right?
This one is the same as this. Yeah. Exactly. And you use this form, you know, to combine the coefficients. Yes, it's the same. It's the same meaning. We just usually don't put the 1x. Yeah. Yeah. This one, yes. Okay. I'm thinking of like what other comment I wanted, I think, to mention. Okay. Yeah. The word of caution is don't lose this minus in front of the x because it goes there, right? Okay. And then negative times negative will be positive 3, right? Okay. So the other side would be 2x plus 2. What we do is we follow the distributive property. 2 times x is 2x. 2 times positive 1 is plus 2, right? And then plus 2. So after that, we'll be combining them, right? So I have these two to combine. So it's like 3 minus 1, and it gives me 2x. The 3 stays plus 3. On this side, what I have is I will combine these two. So it gives me 2x plus 4. And this is where the weirdness comes in, because over here on the left side, I have 2x, and over here on the right side, I have 2x. It's the same. So it doesn't matter where I send it, whether I send these 2x to the other side or these 2x to the other side, the result will be the same. The variable will disappear. Namely, what we will do is we will do minus 2x and minus 2x to both sides, right? Because we're planning to move it to the other side. And what will happen is that they will be canceled. And we will be left with this weird statement that 3 is equal to 4. And we would say, what? Right? Like, how come is that? 3 is never equal to false. It's false, right? And what you could do is you could probably move 3 around or 4 around. It doesn't matter what you do. You will be getting something like a false statement. What it means is that this equation has no solutions. No solutions. No matter which.
Excuse me?
Yeah.
I thought like you were supposed to divide 2 on both sides. You can't take away 2 from x. Like you can't, it's not like you can divide, I don't know.
Let's divide it. Let's follow what you're
proposing. You don't do not 2x, but just, you see how you have 2x, you can't divide 2 on both sides, and then it becomes x to separate the x from the 2, and then add the 3 to the 4, and then x becomes x equals 7. That's incorrect, right?
It's incorrect, exactly. And that's what you're doing wrong. Remember what I told you, if you have a variable, if you have a coefficient, and if you have a constant, you get rid of the constant first, right? That was kind of the first step when we were solving equations, when we didn't have x on the other side. And when we were introduced to the x's on both sides, I said, collect all the x's on one side. Now, this is your kind of first step, right? Now, this is how you could go wrong by dividing, because you're saying divide. When you say divide, you have to divide the entire sides by the 2 completely. So you divide 2x by 2, and you also divide 3 by 2. And same here, you not only divide 2x by 2, you also have to divide 4 by 2, because that's how the rule says. We can add the term to both sides of the equation. We can subtract the same term from both sides of the equation. We could divide both sides of the equation. But you see what I'm talking about? Sides, right? So if you decided to divide, to get rid of the 2 as a coefficient and divide the 2x by 2, you cannot just divide the 2x by 2. Let me show you this. So you cannot do this. That's not allowed, right? The only thing that you can do is you can divide completely the entire side by 2 and completely the entire side by 2. And you can proceed from there. Yes, you can divide this, get x. You can divide this, get this. You can divide this, get x, and then you can divide 4 by 2, get 2. But where does it bring you, right? It brings you to a similar equation, just numbers are smaller and we have a fraction, right? So that's why whenever we have terms with the axis on both sides, we must collect them on one side. And it means move things around, right? So we collect them on one side, we then get rid of the constant and only then coefficient. So it's a very good question that you asked, because this is what we tend to do. You know, you usually, if we're rushing, if we don't remember, like, exactly the steps, this is exactly what we are trying to do. Just divide by 2. And we only divide the 2x by 2. Okay. Okay. So it's really nice to go over this to show what other options we had and why we shouldn't follow them, right? Okay. Let me erase this, and let me erase this one as well, because I'll need the space for the second problem.
What was you saying about it? You just say like if they give you a question like that, just say the correct answer is no solution.
Yeah. Yeah. So, and just think about it. If I try to plug in any value for x into this original equation or this one rewritten one, none of them will work. None of them will give me a true statement, right? Like 5 is equal to 5 or 6 is equal to 6 and so forth. So it means that no value of x will make it true, right? So that's why the answer will be no solutions for us for this particular question. Now, in the second one, if you tried it, most likely, you got something like this, like 3 equals to 3, right? Which is a true statement, because 3 is equal to 3, right? 3 is not equal to 4, but 3 is equal to 3. So there is nothing wrong with it, right? Now, the answer in this case will be a different one. But let's work on this problem first. So I will use the distributive property first, right? And this will give me 3x minus 3. And on the other side, I'll copy over the 3x, but I will combine these two and it will give me minus 3. Right now, at this very moment, compare the left side and the right side. Aren't they the same? Right? They are the same. 3x minus 3, 3x minus 3. Right now, you can stop and give the answer. And if you don't, then what we will do is we will collect the x's on one side, right? So for example, let's send the 3x to the left side. What will I do? I will do minus 3x minus 3x to collect them all on one side, right? But it will cancel both of the appearances, right? And I will be left with the negative. Okay, negative 3. I was wrong. You were getting negative. Oh, sorry. I flipped my screen and it went to another place. I have to come back to you. Okay, here. So negative and negative, right? So you will be getting negative 3 is equal to negative 3, which is true, right? Yes, it's always true. Negative 3 is indeed equal to negative 3. So this is that second special case where you will say that all real numbers are solutions. Now, the more formal way to say it is to say infinitely many solutions. Infinitely many solutions. But if my memory doesn't fail me, you would see all real numbers are solution in web work, solutions. Infinitely many numbers. What the infinitely many numbers means is that like all real numbers are solutions. How many of them? Infinitely many, right? We cannot stop counting them. There will be always a new real number, a new and so forth. Okay. So, two different cases. Let me show myself again, right?
I have a question.
Go ahead.
So for the solution, does it matter for the sign if one is negative and the other one is positive? Does it consider a solution or no?
So, for example, in this case, let me do the selection tool. Okay, so over here, if one was positive and the other is negative, that's a completely different case. I would say that this equation does not have any solutions, right? So no solutions. So for us, it is important, what do we get at the end? Is it, you know, I could write +3 is equal to +3. That's correct. But I cannot say that -3 is equal to +3, right? Because they have different signs. Now, what I could also do is I could add 3 to both sides, and this will give me 0 equals to 0. That's also okay. So anyway, I would rewrite it, what would be still true, fine by us, because it doesn't change the answer. But if I were to say that, so 3 is equal to -3, then it cannot happen. It would be this answer, no solutions. Okay? Let me know if you have any other questions. Or the same one. Maybe I didn't answer it completely. Good. Everybody's good. Okay, so I wanted to show you these problems in our web work assignment. Which one? I think this one. Okay, no, D15. So we are D01. So if you go into our linear equations homework, I think problem number 9 was about it. Yeah, you see? So solve. For this problem, there are only 2 options, no solution or all real numbers are solutions. So this is what I mean. And there are like 3 questions about it, but I think 2 of them are special cases and one of them will be some number. Because for example, here, right, you have these as 2 options, but maybe it has a solution. So I cannot predict that because you are getting different numbers there. They're all generated for you, personally. Right? So my numbers here are different from what you would see. And this one. So there were 3 problems about this stuff, right? That you might run into the case where there are no solutions, or you might run into the case when there are all real numbers as solutions. So for example, here, 8 times 9, what is it? 72. So it will be one of those special cases here. Yeah. Now, what I'm looking at, and once again, what you should look at, I'm getting back to the whiteboard, is you see how it looks like. At some point, you got 2x here and you got 2x here. It's the same terms that will cancel out, right? Or here, we got 3x here and we got 3x here. So it will be gone when we move it, right? Because it will change the sign and they will cancel each other out. So this is what you should be looking for. If you, as soon as you spot one, you say, hey, it's one of those special cases. So let me see, what am I getting? Am I getting a false statement? No solutions in this case. Or am I getting a true statement? In this case, any x is good, right? No matter which value you use, this equation will always be true. We call them identities. So that's another name for them. But okay. Okay. So I'm going to raise everything and put up the questions for today's topics, because you had 3 sections there. One of them was talking about graphing inequalities. Another about solving inequalities when it has only one inequality symbol, right? And then the last one was about the compound inequalities. So we'll see the 2 examples for each of those sections. And then after we're done with the last one, so I have 6 examples for us, we will have the Kahoot quiz, okay? I just, this practice, make sure that everybody understands what we are working on, that we have some kind of basics, because once again, the Kahoot quiz is the easy questions, not many steps, because we want to make sure that you get the idea, right? Okay. So clear all the drawings and let me begin typing them in. So for this one, let's do that it's number 2, right? So solve oh no, not solving yet. No. Here you'll be picking the graph. So choose the graph that represents the given inequality. There will be 2 of them. Quality. Okay, let me stretch it out. And then this is A. So it will be X, and I need the styler. Okay, is less than or equal to 1/2. Okay, that's the first one. But the second one, B, A is A is less than 7. Okay, like this, right? So what I will do is I'll put up the 4 graphs for A, the 4 graphs for B, and then we need to pick the correct graphs, right? That indeed show the graphical representation of the given inequality. So once again, you otherwise will be facing my ceiling, so I'll stop the video and then I'll put up the graphs. Okay, so we'll be choosing between 1, 2, 3, and 4. So this is one of them. This is 1/2. This is another. It's 1/2. This is yet another. It's 1/2. And this is the last one, 1/2. So let me do something. I'll use different color. So for example, this, and then this side. And then from here to the left, or shaded from here to the right, or shaded and from here to the left, right? Okay, so that's the first step. Now, while I am working on the item B, try to see what do you think is the correct one for the item A. And please put it into the chat messages. I'll open them up so that I could see, you know, what you're giving them. Me. Mm-hmm. Okay. So 1. This is 7, 2, 7, 7, 7. And then let's do the graph. So here and to the right, here and to the left, shaded and to the right, shaded and to the left. I see the answers. I like all of them. All of them are correct so far. Yes, all of them are correct so far. That's why I'm not even replying. Yes, and I even see the answers for the second one. They're also correct. Okay, I'll put myself back so that you could see my face. Here, this way. Okay, like that. Okay, yes, I like all the answers. Okay.
I have a question.
Now, go ahead.
So by A, by the letter A, do you mean like 1, like that refers us to 1? Or what does A stand for?
The X. Yes. So it doesn't refer to the first one. No, A here is a variable. And I did it on purpose because we are so used to seeing the X only, right? That if we see something else, we'll sometimes hesitate. No, A here is a variable. It is not connected to the A case, right? To this one where we say that the X is less than or equal to 1/2. It's just a variable. Okay, so so I see that all the answers are correct, and you know, for both A and B problem. And just some refresher for us. We shade the circle when we have an opportunity for equality, like you see here, right? Our K with the case when X is equal to 1/2. It means we should take it, right? So this point should be included. That's why we will be looking only at either case 3 and 4, right? Because 1/2 is included. Now, when it says that X is less than 1/2, it means that we need to take the part, you know, of the number line to the left of the half, because all the numbers to the left of 1/2 on the graph will be smaller, right? So that's why we will be taking exactly this as, you know, for the answer, because when we go to the left of 1/2, well, you know, somewhere we'll get the value of 0, and then it's negative 1/2 and so forth, right? So the number line usually runs that we have smaller numbers on the left and greater numbers to the right, right? That's why the 4 will be the correct answer for the item X. So first of all, 1/2 is included. And secondly, we shade everything to the left of the 1/2, right? Okay, now, let's take a look at item B. Now here I'm using a different variable. Thank you for noticing it, but I treat it the same way. Now here I have a strict inequality. We call them strict because we do not allow the case for A to be 7, right? So it means that I will be choosing between options 1 and 2, right? I just need to decide which one. Now it tells me that A is also less, right? Like, in the previous case, it's less. So we should be shading everything to the left of the 7, right? Because to the left of this number, we'll have the values that are less than 7. Okay. Okay, so yeah, I see that everybody is good with it, and I'll tell you now why do we need it. When we solve inequalities, we graph them. So we have like a complicated inequality, we do something with it, we get the answer, and then we are always asked to graph them. So it's not only that we solve it, but we only graph it. And the Zai books just separated these two topics, right? So first we learn to graph, then we learn to solve, and then we connect them with each other, right? So now let me know if you have any questions about these two problems.
I have one. Can you explain one more time about the shading?
Shaded, yeah. So when we shade the circle, it means that the value is included. So for all these cases, when I say x is less than or equal to 5, I'll be shading this 5, right? So I have the circle and then I shade it. So whenever the circle is shaded, it means I'm taking it. But if I have, let's say, x is greater than 20, right? So on my number line, this is the 20. I will only keep it as a circle, right? Because 20 is not included. Now, when we shade this, you see these ones and these ones, what does this shading mean? It means that every single of these values is taken, okay? That's why we also have to make a decision of the boundary point, right? Do we take it or we don't, okay? Good. Okay, so let me clear everything up. I'll move my board over here and let me put up another set of questions. So 3, right? Solve linear inequalities and graph their solutions. So this is usually how the problem sounds like, right? So it doesn't separate solving from graphing. Now for A, here are my equations. I have 3x is less than 7x minus 28. And then for the second one, okay, I have 9 parentheses x plus 3 closing parenthesis. Okay, now here I have greater than or equal, so I'll use some space and I'll use my styler there for x minus 3. Okay, so and then now let me put that it's less than or wrong color. Okay, less than or equal. Okay, less than or, no, greater than or equal. Apologies, greater than or equal. Okay. Right, once again, we don't have this symbol on the keyboard, so we either draw it, you use math quill in WebWork, or I'll show you how to put it as well. Oof, now check out these two, and let me talk in general about the linear inequalities. We do use the same strategies as we used for the linear equations with 2 differences. First one is that we usually prefer to send all the variables to the left side. So all the terms with the variables go to the left side. And second, we are careful when we dividing or multiplying by a negative number, because in this case, we should change the direction of the inequality symbol, right? So what I will do is I will put these 2 differences in right now, and I will ask you to try to solve, or at least start solving, these 2 inequalities. What I can tell you in advance is in A, you will have to change the direction of the inequality, and in the B, you will not have to do it, okay? So in the B, don't forget to open the parentheses first, right? And in the A, you just be moving 7x to the left right away. So let me just kind of show you the first step, right, in each one of them. So over here, you'll move 7x to the left, and over here, you'll open the parentheses first, then move the 4x to the left, okay? And while you're working on them, I'll put up those two differences. So two things that are different from solving linear equations. Okay. One, send all terms with variable to the left. Second, when dividing, multiplying by a negative number, change the direction of the inequality sign. Okay, so two differences only, right? Now, if you're finished, just in case, if you finished before I will be doing them, put the answer please into the chat, right? I just want to see where you stand. And also, if you are going to use the keyboard, then in order to put, for example, greater than or equal, you will put in greater equal, like this. Okay, this is how we used to do it when we didn't have math wheel, so just the keyboard, greater equal. This is how it's used in programming. So if you're writing a program and you want to compare numbers, you'll be using these sequences. Okay. Okay. So I'll mute myself so that I will not be distracting you, but feel free to ask questions. I'm here. And I'll just follow the steps that I planned out. Okay. The only thing is that I apologize, but I have to turn off my video. Once again, I don't think that you're interested in the ceiling. It's just white. Okay. So let's move it to the left. So I am doing minus, you know what? Let me do another color. I'm doing minus 7x here and minus 7x here, right? So now from here, it means that they will be canceled, right? The 7x minus 7x. On the left side, I am getting the negative 4x, right? Negative 4x. Now, the less I keep for now, but you'll see that I'll have to change it. So minus 28 here. Now, what I have now is the x has a coefficient of negative 4. Be careful. The coefficient is negative 4. It's not 4. So when I'm getting rid of it, I need to divide by negative 4. Dividing. Divide by negative 4. Divide by negative 4. Okay. Now, what will happen to the left is that the 4s will cancel, right? Negative by negative is positive. 4 divided by 4 is 1. Now, what will happen over here is negative by negative will make it positive. And 28 divided by 4 will give me the 7. But because I did the division by the negative number, the direction of the inequality should be changing. By the way, it's a very frequent mistake. It's a typing error, you know, call it whatever you want. But we forget to change the sign, the direction, right? So it does happen from time to time. So don't be surprised to get it, right? Now, not only we need to solve it, but we need to graph it. So let me go ahead and graph it. That's my number line. That's the 7. Do you see that the inequality is strict, right? So x is strictly greater than 7. So I will be excluding the 7. Let me do another color. So excluding the 7, empty circle, right? Not shading it. And then shading everything to the right of it. So this line over here means that every single value over there satisfies to the inequality, right? So it's a solution to the inequality. It satisfies the inequality. Now, for the second one, I'll put up the answer right away before I solve it, because I'm pretty sure that by now you're either finished or you're on your way. So it should be this: x is greater than or equal than negative 6, right? And then we will graph it. So that's what I have for the second one. X is greater than or equal to negative 6. Okay.
I have a question.
Yes, go ahead.
Does that include so you said a negative and another negative? turns into positive, so the sign changes, right?
Yes. Mhm.
So what if there are the opposite sign? One number is negative and the other one is a positive. Does the
We'll
sign
do it
change
negative.
or?
Yeah, we'll do it negative sign. Yes.
All right.
Mhm. Yeah, and you know what? If my memory doesn't fail me, we will see it in this item B. I think this is where the way it will be. Mhm. Okay, but let's use that distributive property. So 9 times x will give me 9x. So this is 9, right? I apologize. G is like this. Now, the 9 times 3 is 27, right? So that's I'm done with. The right side, I'll just copy over because I can do nothing to it yet, right? So 4x minus 3. And then we need to collect all the x's of the variables on the left side. So I'm gonna need to send this one to the left side. So it means that I will be subtracting minus 4x minus 4x, right? And now from here, 9 minus 4 gives me 5x, right? Plus 27. And on the right side, these most two are gone, right? They cancel each other. So I'm having only negative 3. And then we are kind of back to the equations, right? So I have this constant over here. That's the coefficient. So I'm getting rid of the constant first. Let's send it to the other side. Goes there. So it means that we do minus 27, right? So negative 3 plus negative 27, it's the same as to say negative 3 minus 27, right? They both have the same sign, so we add them up and keep the sign. So it's a negative 30, and then over here, these ones are gone. We have only 5x. So the final step now will be to get rid of this multiplication, right, of the coefficient. And yes, and you see this one, this is the situation when we are dividing negative number by a positive number, right? Two things to note here. First of all, the inequality direction will not change because I'm dividing by a positive value, right? So it will not change. And secondly, negative divided by positive will be negative. Okay, 30 by 5 will be, what is it? 6, negative 6, right? So x greater than or equal to negative 6. That will be our answer for this inequality. Now, if we graph it, let's graph it. Negative 6. It's very nice with these graphs because I don't need to put the scale, right? All I need to do is show the number. Okay, now it says greater than or equal, so let's grab the color. So first of all, we do the equality. It means that we shaded, right? And then it's greater than negative 6, so we go to the right, right? So every single point over there is the one that is a solution for this inequality. So it satisfies it, right? Okay, done with this one. Let me know if you have any questions. Okay, everybody's good? Okay, so
Wait 1 second. Let me just see something real quick. I'm just trying to see something real quick.
You're good? You finished it? Let me know.
Yeah, what you divided 3 by 27?
No.
Oh, you minus my fault. Us you
Right.
subtracted.
Right. So we did, where is my pencil? So we did negative 3 minus 27. And what I like to do to myself is I like to rephrase it. I say negative 3 plus negative 27. So I kind of see that they're both negative. So we add them up and we keep the sign. So we are not dividing.
Yeah, I'm done.
Good. Excellent. So let's clear it up and then let's put the last two. It's about the compound inequalities. So let me write it here. Okay, solve, oh, this will be number 4, right? Yes, 4. 1, 2, 3, 4. Yes. So solve compound inequalities and graph their solutions. Okay, and I'll stretch it so that it will be like this. Okay, so A, this is like that, negative 46 less than negative 4 plus 7 parenthesis x minus 3 and then less than negative 11. Now the ones that you saw were much shorter, right? So I have this on purpose to show you how do we work when we run into the situations when the equations like are long, right? Inequalities, apologies. Okay, now the second one, I'll put it here too. I think I will be able to fit them in. So this is what I have, but I'll have to change it. You know what? Oh, I can keep it the same. 2x plus 7 is less than 21. Or, so you see this or means that it's either there or there. But you will see from this example that we'll be combining the intervals somehow. Okay, x minus 3, is less than or equal to negative 5. So let me leave some space here, and then I'll use the styler to add the less than or equal. Okay, so less than or equal, less than or equal. Now, what we will do here is I will direct you what to do. You will do the step, then I will do it as well, right? Because I really want this one to be interactive. I'm not asking you to put any answers into the chat messages, but you know, I'll be waiting on for you to make a step. So let's take a look at the first one. What it basically says is that expression over here, this kind of complicated expression, right, is between the two values. It's greater than negative 46 and it's less than negative 11. And what I'm saying here is the word and, right? So it is kind of guarded, right, on both ends. So we know that it's greater than negative 46 and we know that it's less than negative 11, right? Now, what we usually do to unwrap it to get something like, you know, x guarded, right? So x guarded, right, with some things here, is we undo the operations similar to what we did with the equations or other inequalities, but now we will be applying the operations to all three sides. So now we have all three sides. So here is what we will begin with. First thing I will suggest you do is you open up this parenthesis by using the distributive property and combine all like terms in this expression. So don't do anything with the negative 46, don't do anything with the negative 11. Just open up the parenthesis and combine like terms. Okay, well, let's see what you are getting. You can type it into the answers into the chat, but you know, you could just save your time and not do it. I'll rewrite it later on and you'll see if you got the same one as I did. Okay, because once again, if we usually do any mistakes here, that is because of the science. Okay, so just few, yeah, I don't know, a minute for you to do these operations. Okay, so here is what I am getting. So 46 on the left with the negative, negative 11 here. Over here, I'm getting 7x minus 25. How about that? So this is what I got when I use the distributive property to open up the parentheses and combine like terms. So let me know if you don't see how did I get, like, you know, 7x minus 25, or maybe just the negative 25.
How did you get negative 25?
Okay, so here is the work that I did. I'll put it down here. I got negative 4 plus 7x, because 7 times x is 7x, and then minus 21, right? Because
I'm so sorry, Professor.
Uh-huh.
Sorry to interrupt. I don't know if it's my laptop, but where you're writing is too low for me. I cannot see what you're writing. Sorry.
Can you scroll your screen up? It's like on your, I don't know what you're using, like tablet or phone?
No, I'm using a laptop.
A laptop?
No, yeah, I cannot scroll up or down.
Oh, that's so weird. Everybody else sees the bottom of the screen or not?
Yeah, I see it.
Yes.
Yes.
Yeah.
Okay.
That makes sense.
Okay, so you know what could have happened is sometimes if you use the Zoom, not the Zoom meeting, but the Zoom like on the laptop, it zooms in and it doesn't allow you to kind of, minimize the window. I don't know if, me doing this, it will, it will not show my writing. Try it because I know that you can somehow magnify your screen, right? And then you will not see the bottom. But, while you are figuring out how to do it, let me just put it more to the top, right? So over here. So here we get negative 4 plus 7x minus 21. Do you see where the negative 25 is coming now? Do you see that I'm getting them from these two, right? Negative 4 plus negative 21.
Okay, got it.
Yeah. Okay, so feel free to move the terms around, right? As long as you grab them with the signs. Okay, so let's proceed. Now, what we are going to do is we are going to apply the same operation to the 3 sides. For example, we are supposed to get rid of this constant first, right? We would usually send it to the other side. Well, in this case, we send it to both sides. We'll send it to the right side and we send it to the left side. And what it means for us is I'm doing plus 25, plus 25, plus 25. So you see, now because I have 3 sides, left, center, and right, I have to apply this operation to all the sides, right? Now, after I do it, I will need to divide all the sides by this 7, okay? All the sides as well. So go ahead and do it. I want you to do these steps and we'll compare our results, okay? I'll put up mine in a minute so that we could see what happened, right? So a minute for us to work on it and I'll check the chat messages.
Wait, what do you want us to do?
Sorry, yeah, I couldn't unmute myself. So what I want you to do is to add 25 to all the 3 sides. Jalisha, yes, you can go. Yeah, you need to have the test. Yes. So go ahead and then just watch our recording later on. What I don't like is that you will be missing the Kahoot quiz. Can you go with your phone? Check it out, okay? If you can go with your phone and use it there. So what I want everybody to do is to add 25 to all 3 sides, right? This way we get rid of this constant. And then after you finished, adding 25, divide all the sides by 7. Okay. So, okay. So try it and then we'll compare our results. Okay, I hope you did the work. So now this is what I am getting. I'll put it also on the right because of the bottom. But so it seems that I am getting, actually, I didn't write my answer, so I'll copy it from the chat. So it's -3 less than x and less than 2, I believe. So that will be the answer that we should be getting. I'll do the work now, but I wanted to see if you got this answer, right? Okay, so let me go ahead and add them up. So -46 plus +25, since they have different signs, I'm subtracting. 46 minus 25 will be 21. And the negative I keep because 46 is greater than 25. Now, less than 7x, because these two are gone. And then here, -11 plus 25 will be 14. Then I divide every single side by 7 because I need to get rid of the 7, right? Because it's a coefficient. And finally, we get over here, 21 divided by 7 is 3, with the negative in the front, less than x, and less than 14 divided by 7 will be 2. So that will be our final answer, right? The only thing I'm left is to graph it, right? Let me know if you have any questions. I'll free up the space here meanwhile. Okay. And here, we'll be using it up. Okay, now let's graph it. And once again, since I'm, I don't know what's going on with the screen, what I will do is I'll put the graph here, right next to it, like here. So we have -3, we have the 2. Do you see that the x cannot be equal to -3 and it cannot be equal to 2? So I need to exclude them, right? So exclude, exclude, and x is in between. So everything here is shaded pink, right? That will be the graph for our inequality, right? So you see that it has 2 bounds, right? On the left and on the right, 2 bounds. Okay. Excellent. Now, with the item B, since we do have this or, it means that we will be solving these inequalities separately from each other. So what I will ask you to do is to solve them. And then we will look at the inequalities that we got, right? We'll graph them and we'll make a conclusion there. It will be an interesting conclusion. Usually, when we have the or, like the picture that we should be seeing then is, something maybe here to the left and then something maybe here and to the right and maybe it's shaded, right? Like, usually we see something like this. But this is an example that will show us the 2 intervals, they will overlap, right? And since we do have the or, right, we will kind of merge them together. So for me, please solve this one and this one separately, okay? So I'll give you a couple of minutes to do so, and then I will do them as well. And if you can, please, can you put the answer into the chat? This one at least is not, probably not that long, but I just want to see how we are doing, okay? Yeah, I forgot to resume the solution, but at least, we'll see this, these comments laid out over here. So it will be okay. Yes, I apologize. I did not record the solution. Okay, let me know if you have any questions.
Are we gonna do a few more of these?
With this ones, no, we just have 2. I have a little bit more of them for the practice after the Kahoot. I have 2 for practice, after Kahoot, we can play with them. But just to kind of get the idea of how to work with them, just these 2. Okay. Do you want to do another one with them? Yeah, we can do another one and then have the Kahoot quiz. Do you want it?
Yeah, because I'm still like a little confused, please.
Yeah, okay. Yeah, okay. So let's do another one. So I'll clear all the drawings up And then let me put it up. So it will be number 5, right? Solve the compound inequality. Okay, the only thing I have with them is like they have a fraction, but it's an easy fraction. So it's not something, you know, in particular. And graph its solution. Okay, so now those ones I will draw because one of them has a fraction. Okay, so here it comes. I have 2 over 3x less than 6. Then I have or negative 3 minus x less than negative 1. So it's like the last one, right? Like the or. Like the or. And what I would suggest us to do here is, for example, over here, I would multiply both sides by 3 over 2. You see what I do? I use the reciprocal, right? Now, what it will do is it will cancel these fraction, right? So 3 over 2 multiplied by 2 over 3, everything cancels out. So we will be left with x only. And with this one, I would send the negative 3 to the right side first. And then I'll divide them by negative 1 or multiply by negative 1. So the direction of the inequality will change, right? So try to work on them like separately. We do them separately on your own, and then we will combine our results and do the graph, okay? So also try to work on it, and then we'll see how it goes. Okay, let me work on them too. What I want to show you first is those cancellations, right? So the idea of why do I do multiplication by reciprocal is that I cancel, right? 3 and 3, and I cancel 2 and 2. So x is left alone, it's isolated, right? So this will give me the x, and then what happens here? 6 I can rewrite as 6 over 1, and here 3 over 2. And again, the cancellations come in place. So for example, I cancel 2 from here, get 1, and cancel 2 from here, get 3. 3 times 3 is 9, right? So it gives me that the x is less than 9. And then I have this or, right? And I will do the second one. Okay, but check the math, right? Check the math. Now, in the inequalities, we cannot cross multiply. The cross multiplication works only for the equalities. Okay, so we cannot do the cross multiplication in inequality. Okay, now in the second one, when I'm moving, it means that I add plus 3 plus 3. So it gives me canceled the negative 3, right? I'm getting the negative x here less than, and then negative 1 plus 3 gives me positive 2. Then I have to get rid of this negative sign. It means that I need to divide by negative 1 or multiply by negative 1. It doesn't matter. But also what it means is that this direction, it will change, right? It will become greater than. Here we have x and here we have negative 2. So that's the second inequality that we are getting, that x is greater than negative 2, right? X is greater than negative 2. Is it greater? Yes, it is greater. So the answer, oh, like, you know, it's a weird one. And once again, what we need to do here is we need to understand how to graph them. So we'll graph them one by one. We have the negative 2, we have the 9, right? Now, in here, pay attention to the word. It means or, right? So one of the options is that x is less than 9. So let me draw it to you here. This one, less than 9. So everything to the left, right? Everything to the left. The other option, because we say or, right, is that x is greater than negative 2. So it's from here and over to the right. But then we say, wait. So it's either there or there, like any one is good. So doesn't it mean that we have the entire, like, you know, the entire all real numbers, right? This is another one that you might see. So the Zybox didn't show you like this example of the previous one that we had with it, right? Once again, usually the intervals are, you know, quite separated, right? They're quite separated to us. But, you know, things like this happens, right? Now, the idea here is for you to understand what the or means and what the and means, right? The and means that both must be true, right? Both must be true. But the or means that it's, oh, it's either from there or it's from there. Both are okay for us. And what we got over here is that we have this interval and then we have this interval. So these intervals overlap. And if the value falls into any of them, we are good with it, right? So it means that it's all real numbers for us. Okay. Okay. Now, so this is what I wanted to practice on. And once again, what I have for the Kahoot quiz, it's very simple, right? So there is no, it's like tricky cases for this because I call it like a tricky case. And the previous, you know, when we had with the or, it's a tricky case. I think I gave the one with the and, it's like, you know, easy, like we had, right? But once again, fewer steps, smaller numbers. So don't worry about that. What we need to kind of memorize is the idea, right? How do we do them? So I'll stop the recording.